Okay, welcome back everyone to the Virtual Residency Workshop 2023. This is Tuesday, June 27th, and we're in our second session of the day. Our speaker is Dirk Colbry from Michigan State University, and he's going to be talking about how to do intake interviews. And so I'm turning the show over to Dirk.
Thank you, Henry. I need to share my screen, which always takes me a second because I need to share sound. All right, there we go. How's that working for everybody?
Looks great.
All right. And there's my message for Henry. Where is it? Where's my mouse? Sorry, gang. There we go. So we're going to be doing a intake interview. As Henry said, my name is Dirk Colbry. I'm over here at Michigan State University. I'm faculty in the Computational Math, Science, and Engineering Department. I'm also Director of User Support for our local HBC. And with me today is Wendy Shan. And Wendy, you can introduce yourself.
Hey, everyone. I think I am able to start my video. So if the host can actually enable my video, that would be great. But again, thank you for accepting me here. I am Wendy, and I am a research software engineer from the National Center for Supercomputing Applications in UIUC.
And so today, we're going to be doing the first of 3 Cyber Ambassador talks. So the Cyber Ambassador project was something that was founded about 5 years ago. It was with a grant from the National Science Foundation for cyber infrastructure training. The fun story was I came up with this idea and then learned about Henry's things, and there's a lot of overlap. So we joined forces and we do a lot of work together. But we developed a curriculum as part of this, and that curriculum includes some of the training you'll see today. And we also have a Train the Trainers program, which Wendy was a part of. And for the other 2 talks today, I'll have 2 other people with me who went through our training program. So this whole thing started from an idea that I had while I was a campus champion. That was part of my life. I was the only research facilitator at my small little HBC here at Michigan State. And another part of my life, I did something called Engineering Futures, which was professional skills training for undergraduates in engineers through the Tau Beta Pi Engineering Honor Society. So what I realized is I really liked the curriculum we taught in Tau Beta Pi, although it was getting old. And I thought what I really want to do is share that curriculum with the campus champions. And I think I had the same realization that Henry had, which is these professional skills are really important, and we wanted to share it with this community. And so that was the idea, and we wrote a grant, and as Henry will tell you, it took 4 different writings of the grant. It's 4 different iterations of the grant, but the one that finally got funded, we had a lot of partners listed in it that we were going to share this curriculum with and try to build professional skills training. And probably our biggest partner has been Henry and this virtual residency. So there are 9 modules in the Cyber Ambassador curriculum. It's all open source. And like I said, so you can download them yourself. It's been adapted to a lot of audiences. It started off as Cyber Ambassadors, but it's moved into most of STEM field. I teach it in an undergraduate data science capstone. I teach it in a graduate level course. It's taught all over. This week, we're going to do 4 of the modules, or parts of 4 of the modules. We're going to do a little bit of first contact today. Let's talk tomorrow. And then we've combined leading the change and leading with principles for Thursday. And so I hope you all look forward to seeing those. But there are other modules. There's actually over, I think, 28 hours, maybe 48. There's a lot of hours of curriculum, and it's all modular. So you can pick and choose the pieces that you want based on the learning goals that you have. Speaking of this, we used a lot of best practices in STEM education. We use constructionism and social culturalism. You don't have to know what those are, but if you do, you know which direction we're coming from. There's a lot of choices on how we could have built the curriculum. These are just the educational frameworks I've been trained on, so that's what we used. And I like to point this out so that you know that we're, it's not just random. So far to date, as of June 8th, we've had 10,000 participants trained in our program, 380 participant certificates earned. So these are certificates. If they attended all 9 modules, they get a certificate. And then we've trained 120 teachers to give the material at their own institutions. And we've completed over 340 different sessions. So we're pretty happy with those results. But today, right now, the agenda today, we're going to talk about good intake interviews. And this, again, comes from our first contact module. And we'll talk about what makes a good intake interview and give you some tools that you can use during your intake interviews. Then we're going to do something we started last year, which I kind of think is fun, is we're going to show you some videos of canned examples of intake interviews. And we're going to give you opportunities to critique. Thank you. We're going to critique the people in the videos, the research facilitator, and see how well they did and what they could have done better. And then we'll just do some wrap up. So that's what we're doing today. So the intake interview, we've talked about it a little bit this week already, is that first meeting with a new researcher. It's often you don't know them or their problems, and they don't know you or your resources, right? And so the purpose of the intake interview is to share those pieces of information. And so just as an example, you might meet someone who walks into your office and says, hey, my name is Lauren. I would like to use the HPC for my academic work. How do I get started? As a research facilitator, you got to know which questions to ask. And so you can think about what questions you would ask in this situation, how you would dig in and learn more about their research, how you can tell them what you have and how you can help them. So during this session, I want it to be a little bit interactive. We're going to use something called a chatter. And the idea is I'll put a question on the screen, and then I want you to type in an answer into your chat window. So open up your chat window if you can, have it readily available. And then what I want you to do, I will say the words 3, 2, 1, chat. And as soon as I hit chat, you hit enter. So let me rephrase that again. I want you to type your answer in, but I don't want you to hit enter until I say hit enter. And what will happen is there's a lot of us on this call. I don't even know how many, quite a few. It's going to be like a tidal wave of answers that pop up the screen. And it's just a way to engage. I'll read off a few of them. You can read off the others yourselves. And it's just a way to get a little bit of engagement, but you don't have to be the one that steps up and the first one to talk. And it helps get rid of that awkwardness. Also goes a little faster. So let's practice a chatter right now. I'm hoping everyone gets their chat window open. And I want you to answer this question. Why are intake interviews important? And remember, don't hit enter yet. Just type an answer in, think about it, type an answer in. And I'm going to babble a little bit while you're typing. So give you some time to think of an answer of why are intake interviews important. Hopefully I've given you enough time. I went pretty fast, but I'm going to say 3, 2, 1, chat. Now everybody hit enter. And you see all of our chatter going up the screen, right? So we got they're important, meeting important, provides clarity and ease of work to inform future users, get information as they need. It sets expectations. These are all great. To understand the real requirements and the optimal solution. You need to get to know the problem so you can help solve it. These are all great answers. So that was just a practice chatter. Hopefully you see how that works. And now I'm going to define something here. I want to define an effective interview. What makes it a good intake interview? Well, most of the time our goal is to identify the problems and start to plan for a solution, right? So that is our goal in an intake interview, is just to meet the person, identify what their problems are, and try to make a plan to help find the solution. But I'm going to say that's only half of an effective intake interview. If you can define the problem and work towards a solution, that's great, but that's only half of the way there. The other half is we really want to build a relationship. And so it is really important. All the tools we're going to give you are not only to help you identify those problems, but also build those relationships so that you can maintain them in the future. So some good intake interviews, just some general advice. Ask about their research. I often will have an intake interview which starts off as, I need to use X technology, and so then you start talking about X technology. I almost always step back and say, hey, before we get into that, tell me about your research. What are you doing? Why are you doing it? Those types of really are very helpful. Most researchers love talking about their research, so it helps build that relationship, but it also helps you gain insight to the larger problem. So don't be afraid to take a step back and just ask about the research. When possible, avoid rushing, right? It's not a marathon. You're trying to build that relationship. Now, tomorrow, there's a slight exception. When we're doing these in the breakout rooms, it's going to have to go a little bit quicker than you might otherwise, but that's just so we can get through them all. You want to try to identify the fundamental problems, and you want to be able to assess the person you're working with ability, right? You might know the solution, but you have to know if they're able to get to that part of the solution. And really, one of the most important things you can do is try to figure out what assumptions are being made. Not only the user, the scientist coming to you asking for help, what assumptions are they making? Like, machine learning is going to solve all of my problems. But what other assumptions are you making about what they're trying to do? And if you are making assumptions, and the trick is trying to figure out what those assumptions you're making. So that's what a good intake interview, sort of the high level. Let's do a quick chatter. What kind of questions might you ask in an intake interview? Like, actually type in your the chat a question that you might ask during an intake interview. And actually, in our last talk, there was a bunch of great ones. So if you want to cheat and go back and look at those, that would be great too. But I want you to think of a question, type it. Do not hit enter, but think it through. And I'm sort of stalling so that everybody has a chance to finish their thought. All right, 3, 2, 1, chat. Oops, I scrolled up too much. Sorry, gang. Woo. What's your biggest pain point right now? Oh, that's a good. How can I help you boost your research? What software tools are you used to? Tell us a bit about your research computing requirements. What kind of growth do you expect to see in your research? What is your current resources? Are there any specific reasons why you're using a tool, specific tool? What resources do you need? These are all excellent intake questions, intake interview questions. Right.
All right. So when you actually doing the intake interview, always keep a principle that you are trying to explain things like your conversation partners are 12 years old. Okay, so why 12 years old? Because 12-year-old is a great age that they will understanding everything if you give simple and clear explanation without any assumption for the conversation partner's background. So always keep this principle, and this principle is very useful for both facilitators and researchers. And we will have tools to help you to apply these principles. Dirk, please. Okay, so the first tool is active listening. So for active listening, it actually means that it's a process of paying close attention to both the words and the body languages that the speaker is using. Also, make sure that you not just watch the conversation, you watch the feelings, the emotions of the conversation partners. And always make sure you reflect back to the speakers. Don't let the other side feels like they are talking to a student, right? And when you're kind of doing this reflect back, make sure you are using I statement instead of you statement. So what are the differences? I statement is far much easier to be accepted for the other side than use the you statement. Just think about this example, right? Like compared to, I will say, okay, what I understood about your resources is, and compare to what you said about your resources, right? You feel that the other side will feel that when I use I statement, I am not blaming them. I am not putting the focus point to them. I am seeing what I understand. And this will be a very good way to make sure that, it take care of both sides of emotions. Another critical point is that if you feel there are a strong emotions in the conversation, acknowledge that, but don't do any judgment about that. Like, I know that all of us, almost all of us, have the tendency to kind of ignore the emotions in the conversations, right? Sometimes we try to pretend that everything is okay. We just make the conversation going on, and we feel like everything will be fine. But this is kind of very dangerous, right? Like the hating emotions from your conversation partners, it's kind of like a hating bomb. It can explode sometime. So instead of just trying to pretend nothing happened, acknowledge the emotions of your conversation partners and don't do any judgment about that. Say something like, okay, your sounds really frustrating, so I am ready to help. Or, okay, I can definitely feel your anger. I can definitely feel your worriness. But don't do any judgment. Don't do anything that, okay, calm down, you are ruling conversations. That won't actually help, right? So definitely make sure that you are doing active listening, you are reflecting back, and you are taking care of both languages, body languages, and emotions. And the next tool is reduce jargon. So yesterday, Henry did a very good presentation about some of the jargons that people are using. For example, projection means different words for psychologists, to mathematicians, or to a music movie producers. So before you actually speak, think about what can be considered as a jargon. How you define a jargon? You can think about if you and your listeners have different disciplinary background, culture background, or language background, or you have different kind of expertise. If you have this difference, can you actually really clearly understand the same word in the same understanding? So if not, this kind of word can be recognized as a jargon. And if you have a jargon, think about if this jargon is really essential to help you to solve this problem or to understand the problem. If that is the case, explain the jargon. Otherwise, it would be better if you just eliminate the jargon. So let's actually go for another chatter practices. So think about what kind of jargons you're using as a research facilitators in your daily life, or you're going to use in your intake interview tomorrow. And when I see like 3, 2, 1, count down, and then let's do it together to see what others are seeing. All right, let's think about this. And 3, 2, 1, go. All right, well, we have very good examples. I see a lot of news. Yeah, this is a very common jargon that can be very different in different, softwares. I see dependencies, modules, right? Obviously, modules is also so common. I see CI. Wow. Well, it can be used as a continuous improvement. I like this. Or even HPC. Yeah, HPC can even mean different things to different people. We have CS. Yes, some of the titles are even can be a jargon. Very good, thank you. So definitely think about this kind of jargon, and also think about how you're going to explain it, or if you should actually eliminate them. Absolutely, great, thank you. So the next tool is about paraphrasing. So paraphrasing is try to explain to the other side how you are understanding a complex problem. So by paraphrasing actually require you to listen to your speakers very carefully and then restate the part of the situation that you understand. Obviously, avoid the jargon, right? Always remember that we are talking to the other side as if they are 12. If you talk to a 12-year-old, we're not using jargon. And also, when we actually using the paraphrasing, you allow the speakers to confirm or clarify your understanding right on time instead of leaving some miscommunication later. And also make sure that you are paraphrasing, you're not parroting, right? So paraphrasing is more of reorganize what you are understanding and explain it in your own way. But parroting is more like, you are just repeating what other side is saying without doing any of your own understanding. And the next tool, sorry, Derek. Yeah, it's to ask clarifying questions. And I think we already kind of practiced this. So as a listener, your goal is to understand in order to solve very complex problems. So use clarifying questions can actually help you to actually get additional information that you need in order to help the other side. This kind of questions can be, open-ended questions, so you can understand the overall situation, or can be a very specified questions that you feel it will be very helpful for you to understand like specific concept, right? So what, for example, like we already did this chatter, we think about like clarifying question, like, okay, what kind of programming languages is your software using? And we already see that, okay, what's your current resources, right? Okay, and what's the pinpoints of your projects? So this kind of clarifying questions, it's able to help you to better understand this current situation. So don't feel fear to ask clarifying questions. And the other side, the conversation partners, they will be also very happy if you ask clarifying questions, because they will actually also know that, okay, what kind of points they also need to reinstate or re-explain it. All right, so let's do another chatter. Think about what other clarifying questions you can actually ask in your intake interview. And again, I will give you a few seconds to think about, and then I will do a countdown, and let's see what we all have. All right, ready? 3, 2, 1, go. Awesome. All right, I see we have, okay, what's your timeline? Oh, that's a very good clarify questions. And how does the system work for you so far? How much time you actually need? Or oh, have you run this software before? Oh, that's a good question. Sometimes we don't know if others have, they probably already tried this solution and we don't know about this. And will you work with others? Or do you have collaborators? Very good clarify questions. So we can think about all the parties. Okay, awesome. And the next one, sorry, Dirk. Yes, so sometimes we actually got the request that not totally match our job responsibilities in our intake interviews. And what should you do in these cases? So in the opposite of we just rejecting them, we do want to make sure that we really care about long-term relationship with our researchers. So that means that we are not supposed to just reject them and totally ruin our relations. So instead, we want to try a soft handoff way. So we can point them to the resources that they can find, or we can point them to the correct person, to the correct department, right? We told them that, okay, this is, IT department can help you to help with this, or, other department can help you with this. And also, we are in the age of AI. So think about, using ChatGPT, using Google, or using Stack Overflow, that our point is to let the other feels like we are always ready to help them, instead of really only care for what we think in our job responsibilities. And lastly, before you close an intake interview, always make sure that you either have action items, you have follow-up times. So the goal is to make sure that both of you, when you get out of this conversation, you are actually have something to take with you. It's okay that we're not giving like immediate solutions in our intake interviews to others' questions, but do make sure that you have some follow-ups to help you to further process with these problems and not let this problem live forever. You can set up like follow-up times, you can set up email, just or tell the others, okay, this is our next time for Zoom chat, or tell the others that, okay, before our next meeting, can you send me this and this so I can do an analysis of your problems? So basically, always make sure that before you close an interview, both of you have something to take with you. Eric, you are muted.
I just realized you couldn't hear me, and I was just, that was the best way I could have ever said that, and I won't be able to repeat it ever again. No, I'm kidding. So next, we're going to do some fake examples. And so what I want everyone to do here, and this will actually last the rest of this hour, so I'm hoping we have a good, interesting discussion. But what we want you to do is open your chat window, and then we're going to play a video, and the sound should work. I have tested this before. And what we want you to do is, while the video isn't playing, instead of just watching it passively. I want you to watch it actively. I want you to type in your reactions to different parts of the video in a streaming consciousness. And I'm hoping everybody does this, and it will be a little bit like the chatter. So there should be a lot going on, but we can play off each other's comments. You can say what you like, what you don't like. I really specifically would be helpful if you think back to those tools we just gave you, active listening. Does the speaker in here show that they're listening, or does the listener show that they're listening to the speaker? Do they use any of the tools we gave you? Like, did they reduce the jargon, or did they use jargon when they probably shouldn't have? Or did they ask a clarifying question? If you see those things, or did they paraphrase, right? I'd like everyone to just say, hey, I saw him paraphrase, and that just to practice to help identify those types of things. Before we get started, does anybody want to ask a question? And that's just my excuse to get my mouse ready. So all of the video is made up. You will see me again in the video, and a colleague, Justin Booth. I don't know if Justin's here today. He might be. And we recorded these videos and we're acting out. These are not real world scenarios. And so we're trying to act out what an intake interview might look like, and some different, and we're actually only two different scenarios we'll go over today. But we're going to go through the second scenario twice to see how it can be done well, and how it, sometimes it can be done poorly. So let's start with this first one. I don't see any questions in the chat. Please tell me immediately if the sound doesn't work or something. Hello, thank you for taking time out of your schedule to meet with me. I really appreciate, I really need your help. My name is Dana, and you are?
My name is Jesse. Hi, Dana. Thanks for reaching out.
Nice to meet you, Jesse.
Yeah.
Okay, I'm very frustrated. I have a lot of data I need to process using the Sanborn Strata method, which is better than the more common FCFD method. However, my transient error is much larger than my latent error. I think I can reduce the transient error, but I need to increase the Talholm threshold. But then the software doesn't run on my computer. So I need to make it run on the supercomputer. I was told you were the person to talk to.
Oh, Dana, I'm sorry to hear that. It sounds like you've got a cascading problems here. What is your timeline right now? Are you do you need, how are things working out for you right now?
I mean, really, we've got a paper we're writing. We can't get the results that we need. I would like to submit that paper in a couple months. I have a grad student who's starting this process, but we just can't even get the software to run because the computers are too slow.
Well, we need to get you back on track. My job here in research cyber infrastructure is to, try to solve or figure out where your problems reside and see if we can't bring some clarity to work through these problems. You threw a lot at me in that call. What specifically, can you describe the systems that are running these calculations right now for me again?
Oh, it's my this computer I'm talking to you on. It's my Windows machine.
Okay, so you're working off of a laptop. Are you connecting to a larger compute node, or are you just?
No, this is a desktop. It was pretty powerful. I bought it a few years ago, but I had my graduate student pick it out for us. It has lots of memory and lots of cores. It's about 4 years old.
Okay.
It was top of the line then. It cost us something like $10,000. I can't give you the specs, my grad student could, but it was an expensive computer. And it so far has been doing amazing work. It's just when we increase that Talholm threshold, it just grinds everything to a halt, and nothing works anymore, and the math doesn't get going, and we just need the supercomputer. All I really need is to just take our software and run it on the supercomputer. Because I just needed to go faster.
So who's responsible for writing that code? Is that the work that you're doing, or is that your grad student?
Well, I mean, these are all standard methods. So my grad student typed them up in MATLAB.
Okay.
And then we run MATLAB on this computer. Like I said, they're pretty standard methods. We're not doing anything crazy outside of my field. But it's well known that as you crank up that Talholm threshold, computation just grinds to a halt. And so
I see.
we have been leading the pack in our research area, mostly because of this desktop that has been powerful enough. But then I was told that the supercomputer's on campus, and so we just need to use the bigger computer.
You need to move to the bigger computer. Now, can you think back to what the last time you were able to successfully run this code?
Oh, I mean, I can run it now at a lower Talholm threshold.
I see.
But once you creep it up past 0.7 or 0.8, you're done.
I see. And are you using your parallel computing? Have you explored any of that work?
Well, I do know this computer has, I think, 16 or 20 cores. I can't remember what they bought. So that they told me that makes it run faster.
I see. Okay. Well, it sounds like what we need to do then, if you're noticing that threshold change is what's locking out your code. So we need to get you in front of a resource to sit down and review that code to see if there's a way that we can get it to better utilize the processors that you have.
Okay.
And
why not use the supercomputer?
I think that what we're going to find is the supercomputer is going to provide you the same results.
But why wouldn't the bigger computer run faster?
Well, we don't know that for sure yet. And I think that it's, if you're telling me that the threshold, as you edit that threshold, I think what we may have to, sounds like you've got quite a few resources on that machine already. And my sense is we might be able to get a resource in there to help you optimize that code. And then we can see about how to transfer that to the supercomputer would be one option. I think what we want to do is look at your code locally and see if we can isolate a problem there first before we introduce an entire new environment. Then we will lose understanding of control over additional variables if we just move right to the supercomputer. I think the best approach would be to work with the resources you have and the team that you have currently.
So I have 20 cores on my computer, and I was told that the supercomputer has 10,000 cores. It seems to me that I should be able to do a problem 1,000 times bigger on the bigger computer.
Yeah, that makes complete sense to me, Dana. I think that we should, I just don't know the answer to that. And I think we need to start first with your resources and with your students and take a look at that code, and let's get a person in to give you another set of eyes on that code and see if indeed we can't add just a little more resources or add up that calculation a little bit more and see if we can get that running again on your machine, and then reach out to the supercomputer to see if indeed we can take that code and move it to the supercomputer. But first, let's look at your existing resources before we jump.
Oh, you're the expert. Thank you for helping me with this.
Not a problem. I enjoy this. Thank you very much for reaching out, and let's get another call scheduled.
Perfect.
Great.
I don't know. I think it's fun. So was the scenario realistic? How did people feel? You can open your mic if you want to. Like, is this something you've ever been in a conversation like that with a faculty before? Very realistic. Lots of very realistic. Absolutely. Did anybody, I'm not going to put you on the spot. So that the Talholm threshold, the Sanborn strata method, I would guess no one here is familiar with those tools, because we completely and utterly made them up. That were just made up stuff, because you're going to be in a situation, we can't be experts at every field. There's going to be jargon. And you notice a lot of that jargon was coming from the user, and we can't stop them from using the jargon. We can try to ask clarifying questions. What other things did you notice? Yeah, it was technobabble. Do you think Jesse did okay? I noticed he was struggling there in the middle. Anybody want to voice a thought about that? Jesse was the research facilitator, by the way. Yeah, so the problem was not solved, but the relationship was maintained, and there's a follow-up, which is exactly what you want. Honestly, there's no way to know what's going on here. This particular facilitator, if I were to guess, would be a programmer, right? And they're used to looking at code and fixing code, but not everybody is, and more people might lean towards solutions that are hardware focused. But I think he was right. Based on what was said, there's not enough information to know what the problem is and what's really slowing it down. And looking at someone's code, if that's your specialization, is a good solution. If it's not your specialization, it might not be a good solution. But then looking more deeply into the problem and finding out where the bottlenecks are is a good solution. I mean, it could be that it's running on their 20-core machine and it's only using one core. They're not parallelizing it on MATLAB or something, in which case maybe looking at their code will speed it up. But he's also right that just moving something onto an HPC does not mean it's going to go faster, right? You have to do a lot to leverage all that extra compute power in the form of parallelization and such. So I thought that was a fun problem. Anybody else have any comments? I'll read. Give me a second to read some of these. Yep. Jesse did assume that the code was parallelized, but he wanted to review it to maybe double check that that was true. Plan to isolate a lynchonite partial bottleneck. Yeah, it would have been helpful. I agree with this one if clarify the reasons and distinctions between code-based versus supercomputer-based solutions, right? What's a solution that you throw a supercomputer at? What types of problems will that help? What types of problems will software help? And those types of things are really good. Yep, those are great. So, hopefully you get the idea of what we're trying to do here. Let's do another one. And again, I put the disclaimer up here. To be fair, a lot of these were made up, motivated, let's say, by possible scenarios that were possibly real. So this is about, well, let's just watch this. Oh, and remember to do the streaming thing in the chat. I like that. Hey, my name's Jasper. I work here at our local high performance computing center. How can I help you today?
Hey, Jasper. My name is Jamie, and I am in need of some desperate help right now. I am a faculty member in the remote sensing department, and I am working through a whole bunch of imagery. And what I'm trying to do is some experimental analysis, and we've got a whole bunch of imagery. We're talking about 10,000 images inputs right now that we need to do processing on. And we had this working, and we had our algorithm set up, and we were processing this data just fine. And now we've upped the ante, and we have more inputs now that we need to put in there. And things are just slowing way down, and I need some help and to figure out how we can keep moving forward. And I'm feeling like the supercomputer might be my answer.
So can you tell me more about your analysis? I mean, how long does it take to currently process your images, and what kind of computer are you running on?
You know, we're running on the state-of-the-art Windows machine. We've added as much RAM as we can to the machine. We've got the video cards. We have cooling systems in there. We're ready to go. The second, you know, it's about 10 minutes per image that it has to go through pixel by pixel and to do comparisons and analysis. And we are, you know, we've never used a supercomputer before, but we just know it's got to be the answer. to our problem.
So when I hear image data, one thing that comes to mind is the results of one image dependent on the results of another image? Are they independent results? Does that make sense to you? So could I run, does it matter which order I process the images in?
You know, it doesn't. It doesn't matter. We've got a set of algorithms on each that are looking for they're looking at the patterns in each image, and they're off-putting data into the statistics that are valuable metadata for each image.
No, that's good. So if it was like a video where, you know, one frame depended on a previous frame, it gets harder. But with independent analyses, that means we can run them on separate computers at the same time. And we call that parallel processing. So,
okay.
So if you're saying it takes 10 minutes to run a single image, if I do that calculation, which I did on my little Google calculator here, it will 10,000 images will take approximately 65 days to run the way you have it written.
Yeah.
Now, that's where your slowness has come. Now, there's lots of options that we could consider. One is there anything we can do to optimize the code? It sounds like you got a very good desktop computer with a lot of resources, and you're probably not utilizing all those resources effectively. So we could look at the code and try to optimize. That could be one thing to do. But since it's giving you analyses that you want, the other thing to do is we might be able to port it to the high performance computing center. And our system, you know, a standard allocation can run on 500 computers. And so now your 10 minutes per image of 10,000 image divided by 500 computers means we could run it in about 3.5 hours.
Oh, that would be fantastic.
What I like about that is that doesn't break your current code, right? If it works on your computer. Now, I don't know if it will port over. You said you're running on Windows.
Yeah.
Our HPC runs on Linux. So we'll have to look in that. There's also a possibility that there's some efficiencies in the code that we could add that might solve all of our problems, and you can continue to use yours. But these are the types of things I want to look at with you.
Okay.
And so, yes, we can do that. Does that seem like a reasonable
But Jasper,
solution?
that sounds expensive. You know, is this something that you have resources that can help me with this?
So
you know, I've only got a few $1,000s left in my grant.
So that's very wise. So right now, the HPC on our campus is free for all researchers.
Okay.
But up to a limit. There are also national resources that are free through the National Science Foundation called Exceed resources. We can get you on those if we need to. There are lots of free resources. Some of them require, like the Exceed requires you to write a short proposal, that kind of thing. But they're very large resources, and we might be able to do that. So
okay, well, it was my grad student that wrote the code, so that's, you know, that he's off on an internship. That's not. Can you guys help me with that code?
Well, we don't have coders in our lab, but I would be happy to spend a few minutes looking through it with you, because my expertise is coding. I will not be rewriting it for you, but I should be able to identify if there is some obvious problems with the code or obvious speed ups that we can make.
Okay.
And I'll do that for anybody on campus, right? Give me about an hour with you in the room, and we'll look at the code together, and I'll see if I can see anything obvious. If not, we can still run on the HPC. Even if it's non-optimal, we can get it down to 3 hours instead of, 65 days.
Yeah, that would be a great start for us. Thank you, Jasper.
Yeah, happy to help you, Jesse. And I hope to see you soon. Let's reschedule a meeting quickly and have you, let's look at your code.
Great, thank you.
Right, that was fun again. All right. So, was that one realistic? Anybody deal with GIS codes? In that case, the research facilitator didn't know much about GIS. I can tell you this because my guess would be the researcher was using ArcGIS, and that actually is quite tricky to get running on the HPC, but we didn't include that detail into the scenario. The scenario was about the people, the relationships, and trying to solve those problems. And sometimes, you want to say, you want to be helpful. I like the old statement that Henry uses. You don't say no, you say yes if. And so the idea is you can solve the problem, but you might need something like resources or something. And you try your best to avoid saying no to the researcher. And you're there to help, but there might be a really big if. And so, yeah, thinking about that as anybody else have any comments? I'm reading through these now, so you can voice them out loud while I read. Again, we didn't solve the problem, but outline potential pathways to a solution. I think you're going to find that true with a lot of intake interviews. Rarely is that first meeting the one that solves the problem. I mean, it does happen. There's nothing I like more than having a very first meeting where a grad student comes in with their code. I spend a few minutes looking at it and I find that, they have this actually happened, a 22 nested loop. And I just rewrote the code a little bit to change it. And all of a sudden their code was, instead of taking 7 years, was taking, 7 minutes. That's very satisfying when that happens. But that's rare, right? You don't always get those. And most of the time in that intake interview, you're just trying to get a feel and get you moving towards that path of getting more details. All right, how are we doing time? We're doing great for time. Any other comments or questions? It's fun. It's really easy to give good guidance, by the way, when it's scripted. So, all these comments, that good advice. Yeah, it's super easy to give good advice when I know what in these artificial scenarios where I'm pretending to actually be a research facilitator. I mean, we didn't have a complete script, but we did talk it out beforehand. It gets a lot harder when you're live and in real time and you're trying to think through all these things. And that's why we do this practice. All right, let's do one that is a little different. And this one includes evil Dirk, and see if you can tell the difference between regular Dirk and evil Dirk. Not really evil. Sometimes I ask to write up their workflow with instructions so that I can reproduce it and send it to me before they follow up, help organize thoughts. I do that a lot, Asher. So I will often work with someone and I say, look, if you can send me something that I can reproduce the bug that you're getting or reproduce your workflow, just something small that I can do that, it will make my our meeting go a lot better. Now I have to agree to spend the extra time to do that, but a lot of times that's very much worth the time just to see what they have. But it will depend on their ability to package up an example in a way that others can interpret, which is actually a skill. All right, let's look at this example. Welcome to my office hours. How can I help you today?
Hi, my name is Jamie, and I am a faculty member in the remote sensing department, and I could really use some help. I'm running some compute on some satellite imagery, and it's just not working out for me. My resources are locking up, and I need to talk through a way to move this to the supercomputer.
Okay, can you tell me a little bit more about what kind of calculation you're doing?
Yeah, I've got thousands of satellite imagery. I'm doing comparisons of their pixel values. We're doing some nearest neighbor calculations. We're looking at all of this data, and we're trying to seek out some reflectance values that will help us with some climate change data that we're deriving from this. And we're just getting more and more data, and it's just getting more and more complicated. I have a state-of-the-art machine in my office with some GPUs and some great cores that are helping us get this work calculated. And the more data we add, the more cumbersome it gets.
So why do you think moving the supercomputer is going to help you?
Because it's super, right? It's got more.
It is.
It has, you guys, there's more resources, and it just felt like I needed to throw more resources at this algorithm to make it push through. And we're we're getting more, we're getting some great feedback in our analysis approach. And so I'm expecting thousands of more imagery that we'll be able to put into this process. And so our initial white papers on this are getting some good feedback, and we're ready to start to expand this. And the more I expand it locally on our machine, the more trouble I get with the compute time.
Excellent. So all you need to do is fill out our form to get an account. And then you can use standard SCP to upload whatever code and files you need to the computer. And then we'll have you write a Slurm script, and you can submit a job, and you'll be up and running in no time.
You know, my graduate students are in the field for the summer. That's not, you know, so being able just to hand off the, you know, upload code is not going to work for me.
So what do you need? I mean, it's pretty straightforward stuff.
Well, it doesn't sound like it. It sounds like you're asking me to do all the work here. Are you, you know, what's SAP? What's, do you need an account number? Is there a cost associated with this work?
So using our local HPC is free, but you know, you have to use it. It's a supercomputer. It's not, you know, it's not an average person computer.
Okay.
You need to use, you need to get an account. You need to log in. It's all free. We have a wiki, and we have a bunch of videos on how to use the system. Just watch those videos. You'll get on, and you should be, you know, it sounds like your system should be pretty easy. And if you, you know, have problems, you can submit a ticket to our ticketing system.
Okay. So this is a free resource, and, you know, I've been doing a lot of research, and I have a lot of, you know, indirect costs come from my grants that I thought helped pay for these types of resources. And now you're telling me to just get in line and fill out a ticket? Is that what we're doing here?
Yeah. So it's all free. You know,
Okay.
we just provide, you log in. We have a pretty standard interface. And if you're not familiar with it, you could come to one of our tutorials, which are fairly regular. And if not, we have some online tutorial help. I mean, it is a supercomputer. It is not easy, but it's pretty straightforward. If you're running it on your local computer, you know, a savvy programmer should be able to have no problem porting it to the HPC.
Okay. All right. Well, you know, I have some collaborators at other universities that, you know, have some resources. So maybe I'll work with them to look for another solution to this problem.
Oh, that sounds like a great idea.
Okay. Well, you know, thanks for your time, I guess.
All right. You take care.
Bye.
So weirdly, that was the hardest video to make. It was hard. The mustache help, I think, right? I used the Zoom mustache feature, and so I got myself a little mustache to try to be evil Dirk. But we also wanted to show that, you know, is evil Dirk, or what was his name? Jasper. Is Jasper, Jasper believes he's helping. I would say that, right? He thinks he's helping, but he hasn't gone through our training. And so he doesn't realize that a lot of what he's ignoring things like emotion. He's jumping way to conclusions about what's needed. He's really just answering the initial question, which is a common problem, right? You say, I need to use the supercomputer, and then he jumps right in to say, okay, you need an account, and this is where you go, which is not necessarily helpful. Asking those clarifying questions are really important, trying to really get into understanding. And I'm hoping you see the difference between this video and the first one I showed you, and some of the differences. What other things did you think? Yeah, evil Dirk sounds like help desk standard operating procedure, right? Oh, I hate ticketing systems where your metric of success is how many tickets did we close? Oh my gosh, that just drives me nuts. In fairness, we point folks to our docs for common requests all the time. Simple stuff like using anaconda. Absolutely. It's okay to point people to the to your documentation. The documentation is there as a resource. What I think was noticeable about this particular video was the person wasn't paying attention. They weren't actively listening to the researcher. They were going through their script in their mind of what we need to do to get you on and running, and really not paying attention to the body language or anything of the other researcher. And I know it was overdone and not exact, but I like this video a lot because it is overdone and it helps emphasize those social cues that might be more subtle when you're actually doing this in person, right? It can be much harder to identify those social cues in real world situations. And so by overdoing it, hopefully you can see what we're looking for. Yes, we've seen far worse than evil Jasper. Thanks, Henry. Yeah, he was at least trying. I've worked with researchers and people in IT that truly think they know what they're talking about. They use tons of jargon, and something that seems extremely simple to them must be simple for everyone else. And that's a common reaction, right? You think it's easy for yourself, therefore it must be easy for everybody. And it can be very off-putting if you don't do it right. Ignorantly eager to help. I like that, Kyle. That's really good. Yeah, not offering to meet or help with things and being condescending is not how to gain trust. Absolutely. And I did it on purpose. I always feel like I have to put caveats in here. I would never do this for real. I like to think of myself as a much better user support person, but it was hard to be the bad person. I thought it was going to be fun, and it wasn't. I didn't like being the bad. I didn't like being bad Jasper. All right, we're doing good on time. Other thoughts? I'm the only one talking. It's really hard to do this when I'm the only one talking. All right, let's go on. Let's do one more chatter. Think about tomorrow. You're going to be doing this, right? You're going to be doing this in small groups. And we haven't given you all the instructions yet. We'll do that tomorrow. But like, based on what you learned today, what are some strategies do you have for tomorrow's intake interview, not knowing the rules yet? Like, you're going to be, we've only really just told you that you're going to be doing intake interviews. What strategies might you have to do that? So I want you to type it in, but do not hit enter yet. Think about what strategies you have for tomorrow. I'm going to give you a little bit more time than usual on this one. So make sure you type something in so that, you know, everybody has an opportunity to not be the only one that puts their answer on the screen. All right, that should have been enough time. All right, we're going to do the countdown in a second when I can move my mouse. All right, in 3, 2, 1, chat. And they're off. Ask questions for clarification. Listen first. Ask a lot of questions and paraphrase to make sure you understand. Absolutely. Listen with I hear statements. That's also very good. Pacing and listening more than I talk. Clarifying questions. These are all great. I like you listed my tools. Active listening, less jargon, establish a relationship, paraphrasing. Great stuff. Establishing connection and watching for connection emotion. That's good. Don't be condescending. That's an excellent one. To do items and follow-up dates. Yeah, I highly recommend that. When I was new, I would often make the mistake of, yeah, we know now what to do. And then we would end a conversation where I felt like the researcher knew what to do and was going to go off and do it. And the researcher felt like I knew what I was going to do and I was going to go off and help them. And we both just sat and waited for each other, right? You need to sort of end that conversation with saying, who's going to do what by when, and make sure that that gets, those expectations are set. Yes. Excellent. So we're a little ahead of schedule. I know you didn't want dead air, but that went really fast. I would like to acknowledge the National Science Foundation for giving me money to build this curriculum. If you have more questions, do not hesitate to send me an email about the Cyber Ambassador program. I'm happy to share it with you. So what other questions do you have now? We can open it up for just general discussions about what we learned today.
Is it okay to unmute?
Oh, yeah, I'm having a hard time hearing you, but go ahead.
Can you hear me okay?
Okay, I can, yes.
Thank you for the talk today. I was wondering, what does one need to do to get access to that certificate? Where's the rest of the resources for completing this program, this curriculum?
So the Cyber Ambassador program, the certificate is only a participation certificate. Not that there's nothing wrong with a participation certificate, but we have 9 modules. We tend to teach them every semester. So we are on an academic calendar. So over the summer, we're going to do all 9 modules. We do them in online in 3-hour segments. But any of our trained facilitators will also be conducting their own workshops, and they're designed to be overlapped. So they all use the same attendance form. And if you attend the session like you're attending this now, we have record of that. And then once you complete all 9, we send you a certificate. If you would like to be a trained facilitator, we do a train the trainers, where we teach you about the curriculum and how to give effective training seminars. And we just did our last big in-person one, but we're planning to do more in the following year. We're writing a book, and we're going to have online train the trainers opportunities. So if you're interested in any of that, I'm there. We're in collaboration with Henry, but I don't want to take too much time advertising my program on Henry's dime.
You go right ahead.
Other questions about intake interviews? Oh, and thanks, Wendy, for throwing up the Cyber Ambassador website on the chat. Oh, Wendy, I went so fast I forgot to switch you. Did you have anything else to say, Wendy?
No, I mean, like, thank you so much again for accepting me to be a co-facilitator. And I learned a lot also from the research software engineer perspective. I don't know if any of the audience have like similar, background as me, but as a, research, software engineers, sometimes we really need to do something kind of like, intake interview. And we have some tendency to, include some jargons that is so common in our communications in the daily life, but we totally assume that the other side, especially the researchers, they probably don't understand what we are talking about. And another thing that I guess sometimes like programmer like us, we try to go, we have a tendency to go to solutions very fast. And sometimes that's actually not a good way of doing this. We should actually ask more clarifying questions to fully understand the researchers before we go, directly to say, okay, here's a solution. I can, review your code. I can blah, blah, blah. But before that, try to understand, pause a little bit, understand what researchers actually really want. That definitely helps for both of us to keep good relations also. Yes, so it's a great, I really like our presentation, and also the Cyber Ambassadors program as a very new facilitators. I think it's also very useful for anyone who want to improve their basic like facilitating skills.
Yeah. There's some actually questions I went on that are going on. How long will faculty remember if you treated them poorly? And Henry's response was bloody forever. That is so true. It amazes me. I've had faculty that have had years of good experiences on the HBC, and literally with one bad experience, they say, oh, the HBC is crap, and they move on. And I have to go back and constantly repair those relationships. And it's actually quite interesting how just one bad experience can really make people feel like the whole system is bad, no matter how much effort we put in to make it better. Yeah, one of the questions that I've been getting a lot lately, and my background happens to be in artificial intelligence, which has really hurt me, recently. I get people saying, I want to use AI to solve my science. I get that question so often now, and my knee-jerk reaction is to say, oh God, not another one. But really, sometimes we can use machine learning or AI to solve a problem. But with this chat GDP and stuff, people think that, oh, it's just a miracle. All I have to do is point my research at chat GDP and it will write my science paper for me, or something similar. And yeah, that's the one I keep dealing with lately, is I have to ask a lot of clarifying questions and really set expectations that, yeah, it looks powerful, but it really depends on what problem you're trying to solve, whether machine learning and artificial intelligence will help your problem. That's just a side note from me. Do you have a session on repairing relationships after negative incidents? I do not, but that's a hard one. We do have a session about communicating problems, which can be to help. And the idea of communicating problems is a lot like what we say in intake interviews, right? Your goal of communicating a problem where you're talking to someone and telling them that there's a problem, you want to communicate that problem, but you also want to maintain that relationship. And that's always key. You're always trying to rebuild relationships or maintain those relationships with any communication that you have. I have had some extremely poor reactions, and I've had people literally swearing at me in the hall because the HBC didn't do what they wanted it to do. And I can think of one particular relationship that's over 10 years old now that I've still yet to be able to repair, even though I've put out an olive branch many times. And sometimes you just can't. If there's a lot of those relationships that you can't repair, you definitely want to turn the lens back on yourself to see what you might be doing wrong. But when I look at most of my relationships and I can see one example of one that didn't fit, I like to think maybe it wasn't me. Oh, good question. Are takeout interviews a thing? I've done, and it's probably a bad name, but we've done postmortems with many researchers where something didn't work the way they expected. And so then I'll bring them in and I'll say, okay, let's figure out what went wrong, and try to come up with solutions so it doesn't happen again. Retrospective, that's a good, postmortem is probably a terrible name. Do we have a systematic way of collecting feedback? We used to have a form, and we're thinking about bringing it back, but it went away. That was the only other way people could give us feedback was verbal feedback or in-person feedback. I guess that's the same thing. But I think we have an evaluation form that they can click on, but they have to go find it on the website. I wanted one a little bit more prevalent, but we don't have one right now. Neurocracy, I can't even say that. All right, other thoughts? Henry, I'm still early. Do you want me to drag out time?
Well, there's lots of discussion going on in the chat.
No news is good news if there's no complaints. Yeah, unless no one's using it. Yeah, I really, really personally love doing intake interviews. I don't know, there's something about meeting a new researcher, especially when you ask them those questions about their research, right? And they get all excited. I love learning about other people's research, even if I don't understand it. I think it's super fun. And so I find myself, I have to hold back on doing the intake interviews because I want to do them all. And I have a team of research facilitators and they should be doing the intake interviews, not me, but it's still something I love to do. What's the best approach for working with super users, those who think they know more than you? Honestly, everybody I meet knows more than me in some way or another. Right? They do, and they know more about what they need than I do. And I think having that attitude is really important. Yes, I might know some tricks that might make that they don't know, and we can teach each other. But honestly, if a power user comes to me and they say they want something, and I just, I stand back and let them do what they need if they have specific questions. One of the things we do that I'm really proud of is we have a curated list of examples. They're on the HPC. They can just type a command called get examples, and up will pop a list. And what's neat about that curated list is if they type get example and then the example name, it downloads the example and they can run it. And those are curated to run on our system. And so experienced users really like that. So if I get some Mathematica user or something, and I'm not a big Mathematica person, I can just have them download a get example for Mathematica, and they can see how the little hello world for Mathematica works. And then that usually is enough to get the power users just off and running. They only just need an example for what's special about our machine. And once we show them that, they can just move on. Anyways, I went on a tangent. Yeah, interactive man pages. That's exactly what we do with our examples. The hardest part about them is curating them. Just a warning, if anybody gets a good set of examples, the best examples are ones they download and just work, but your system's always updating, software's always updating, things are always changing. And so you don't want someone to download an example and have it not work, because then they think, oh, it's something they did, and it just stalls it out. So I work really hard with our team to make sure if we provide an example specific for our system, that it always works. How do I keep our team trained and relevant? Well, I don't know. That's a good question. We just are always, we meet weekly and we always encourage continuing learning and improvement. And we send them to the virtual residency. Although I didn't look, is any of my team on here? I'm going to call you out now. There's a lot of people on here. Holy cow. How many are on?
107.
Oh, Chuck was here. That's one of my team members. You win extra bonus points, Shelga.
I just want to really add something to the conversation about how like worlds collide. Is while we're doing this right now, we're bringing up an HPC at my campus, and we're having a new user that's not part of the core original committee. And just at 11:30 was a proposed new user workflow. I'm like, oh, I'm doing intake interview training right now. So it was a great, actually send the email to the group. It's just funny how sometimes worlds collide like that. So.
No, that's great. Well, good luck with your intake interview.
Hopefully it'll be later after this week so that I can take what happens in this week and apply it to the actual real world.
Absolutely. You know what I find a lot, that, this will be my closing remark. What I find interesting about professional skills is what we're training here. Like when I say professional skills, people call them soft skills. I think that has a negative vibe. So we always say professional skills. But those professional skills, communication, teamwork, and leadership, they're important to practice. They're obvious. Nothing I said here, nothing Wendy and I said was earth-shattering or new, like, oh, you have to do active listening. Duh. But by saying it out loud and practicing these and watching people do it wrong and thinking it through, it makes us better communicators. And really, it's not something you read and learn, it's something you do through practice. And so the whole point of this week with Henry and everybody here is to tell you the obvious sometimes. But giving you practice, it is important to state the obvious and practice doing it in a safe environment where you're not going to make any big mistakes. And that's what we're trying to give you with this week of education, is just to practice doing some of this stuff, which is obvious. But even though it's obvious, doesn't mean that it's second nature to you.
For some of your approach, I come from the help desk, so I have HDI training and some ITIL exposure. Have you incorporated any of those into how you manage your like first contact?
I missed what those were.
ITIL is an international how to run a help desk. It's like a training on how to run a help desk. And HDI is help desk something. It's in like, I think that group is since retired. They couldn't survive COVID. But they're essentially just tools that you would send your help desk, your standard central IT help desk to for training. And ITIL is, of course, the structure in which you build the help desk. So I was curious if you've had any of those integrations.
No. So first of all, it's obvious to me that those tools exist now that you say that they exist. Like there's obvious to me somebody had gone through and figured out what's good practices for help desk. Two is I've never heard of that before. Could you send me an email and tell me, like, at least put it in the chat here of what those acronyms stand for, ITEL and stuff. Because yes, now I'm going to go back and see that people smarter than me have already thought this stuff through.
So that one is so that's the one that still exists, and it's kind of like the CompTIA equivalent of a standard structure, right? It's going to touch every single aspect of the help desk.
Excellent. Thank you so much.
And the other one, like I said, is done. I think let's just see if they are actually exhausted.
Yeah, it's very
There's a
possible.
lot.
We recreate a lot of stuff that's already been created. That happens all the time. But it's smart to listen to other people who have thought it out because they're clearly smarter than me.
And that's the other one.
Thank you.
They are still around, which is good because that means I didn't spend a year training for nothing. All right, I'm hopping off here.
All right. Well, I think we're done. Henry, what you want to close us out?
Yeah, you bet. Okay, so this was a great session, and I thank Dirk and Wendy very much for putting it together, and Justin and Evil Dirk, of course, who did a marvelous job. And I want to thank all of you for making this an incredibly interactive session. I think that's absolutely what we want to accomplish in the virtual residency. And we're now in our lunch break, so an hour and a half. So at past, not this hour, but the next hour, we'll be coming back, and it'll be me. I'll be doing the components and design of a high-performance computing cluster. So walking you through the machine. And then that'll be followed by the cyber infrastructure landscape organizations, presented by Melissa Cragen of Rice University. So we're looking forward to seeing all of you. Danny, you have your hand up.
I was just wondering if anybody wanted a social host, because I can hang out for about the next hour and a half before my afternoon meeting array claims me.
Oh, that would be great. Yes. And of course, we're leaving the session open. So people are welcome to hang out and chat and have a good time. Oh, and let me kill off the recording here.
Cool.
Yep. Okay. So hang out, stick with us. We'll leave the session open, and we'll pick up with the next session an hour and a half from now.
It says it's still recording.